All right, folks, it's time to get started building the application that we went over in the introduction. So I wanted, before we get started, to show you a diagram of the overall application that we'll be building. This diagram is a little bit busy. It's got a lot in it, but hopefully by explaining this, you'll have a better idea of what we're doing. As you can see here in the diagram, we have 4 separate applications. We have an account API, an account client, a memorizer API, and a memorizer client. So all 4 of these applications will eventually be run inside of Docker containers. And to handle these incoming requests to these containers, we're going to be using Traefik. So as you can see, there's an arrow of incoming requests coming into Traefik, which is also inside of Docker, and depending on the request URL, the Traefik will be forwarded to a specific application. So in this tutorial, we're going to scaffold out the Docker files and the Golang application for the account API, which is seen in the upper left corner. All right, so I'm in a folder called Memorizer, the name of the application we'll be building, with a Git project that or Git repository that I've already created. So if we hit ls-a, we can see that we have a Git repository here. And I've also created an account folder, which is the folder which will be hosting the Go project. Furthermore, I have a code workspace file, which I'll show you here, which is basically just a JSON file, and this is used for VS Code to set individual projects as workspaces, individual folders as workspaces. So you can see that I've added account and the root directory as workspaces. The reason that I've added account as a workspace is just a factor of the Go language server in VS Code. So in order to work with Golang projects that use Go modules, or Go projects that have that go.mod file with the list of packages, we need it to be defined in a workspace. So this is just a matter of how VS Code works in Go. So you don't have to do this, but if you are using VS Code, you may find it convenient. So the next folder is the root folder, and that is because we're going to use the root folder to add environment file, and Docker Compose, and a JSON file that gives us access to Google Cloud Services. So I just want to be able to see all of the project folders nicely in Visual Studio Code. You can open them separately if you want the Go language tools to work. So if you just opened up the account folder by saying code, account, that would be just fine. And you could have multiple windows. But for clarity in this project, I would like to be able to see the whole folder structure. Now that was a lot of context to do something basic. Unfortunately, neither VS Code nor the Go language server tools looks like they want to change this, and in the written article I have some notes. So this is off to a great start where I'm griping about features that I have no control over. But anyway, never mind, let's get started. Let's open up this workspace file, which will open up VS Code. All right. Oh, there's a deleted file that I already created. So the first thing that we want to do in this account folder is create a file called main.go, which is the entry point for most Go applications. So as per the standard of Go applications, we're going to first create a package name. All right, and then we'll create a main function. And what else can we do other than say, hello world? Or maybe we'll be coarser and say, hello suckers, with a Z. Yeah, that really will get them. And we can go down here into the terminal and run go. And you can see I was already just doing this from my terminal, but let's do it again. All right, hello suckers, looks good. I don't know why I'm so rude and angry today. All right, so within this folder, I'll clear the terminal. Let's initialize Go modules. So this is, if you're familiar with Node, this would be like your package.json. It's just going to list all of your dependencies. And it's customary when we do this to use the name of our repository or wherever it's hosted. So for example, I'm going to use go mod init, and you can see here I've added the GitHub repository name for this. So if you want to find these notes, you can go to this GitHub page and you'll see the repository. So that's just a standard naming convention. You might see some hosted by Go, etc. I guess I've listed one thing, so I don't need to say etc. But here we go. Let's initialize the module. And you can see we've created a Go mod file. Right now, it just gives the name of that repository or the module, and then the version of Go we're using. So any submodules, if that's the proper name, inside this project will be like /handler or service. So we'll be creating more packages later, but this is sort of the root package. All right, so we're running hello world, and we have the main function. Let's now add a web framework for Go called Gin that I really like. There are some options out there like Echo, Martini. There are a lot of them in Go. But this is one that I think is very easy to work with and has documentation. So we're going to go get, which will add this package to the Go module. And I think the U is -U is just to say upload all of the most up-to-date. So for the dependencies of Gin, get the most up-to-date patch versions. But if you go Google it, there's a nice article on Go modules that will explain that well. All right, so you can see we're getting Gin and all of its dependencies, and we have this Go sum file, which is all of the versions of the modules that we have, and Go mod. So you can see we have all kinds of these here. Anyway, not a course on Go modules, but I like to talk a lot and get distracted. So yeah, live with it, or, give me a thumbs down. What do I care? Well, I care a lot. I'll probably cry if you give me a thumbs down. I'm very sensitive. All right, so let's now get a server going here. So the first thing I'm going to do is just create some logging here with the Go library logger. Now, the nice thing about the logger is right now, if I just save this, you can see I imported the log. The Go tools are nice at automatically importing the standard library for you. So you could also import log from other logging services like Logris. What's the one that's hot these days? I'll have to look it up. I can't remember. But those tools, you also use the namespace, if that's probably not the proper terminology, but they also can be called log. And so you can kind of just replace this logger with another library, and that would give you colored output, info, error, leveled logs, if you will. The next thing we want to do here is set up a router which will help us map REST API endpoints to actual handler functions, meaning so if you type /posts, memrizer app /posts, it will then run a certain function. And this is standard for web servers. So let's create this router, and we'll use the assignment operator like we do in Go, but this is not a Go course. And we're going to create a default router. If I command or control click this, I'm on Windows, so it is actually control. I guess it's not importing Gin. Import Gin. All right. I had to hit control period to import that. Now, hopefully, if I click this, you'll see this creates something, a reference to something called an engine. And it basically, this engine.use is using some middlewares called logger and recovery. So the logger, you'll see in development, it just prints out the HTTP status with a nice color so you know if it was successful or failed or not found. And then it also adds a recovery logger. So if you have some code, some error that's not handled and you have a panic, this way your application restarts and keeps running. I'm pretty sure that's how it's handled. All right, so we have this router. This is just a warning saying that it's not used. So I'm going to actually, for now, just create a simple get route at API/account. So we're not putting in the domain name here. We'll handle that in our reverse proxy. But then we're going to add a handler function, which in Gin is this callback. And Gin takes this, it has this context, which kind of has the HTTP response and request. You might be used to seeing the rec and res type thing in a normal HTTP router in Golang. But this C just kind of has some convenience methods and tools on it. So let's do c.json, and we're going to return http.status OK. These are just some, I think they're enums or just strings, constants saved in the HTTP library that have the status number for each status. So a status OK is a 200. And so it's just nice to name them like this instead of writing out 200, which I suppose could be a little more error prone. And then we're going to return gin.h, which is basically just a gin.h, if you look at it, is just a map of string to interface, which interface in Golang basically means anything. So since we're returning JSON, we just want to make sure that this anything interface is serializable so that JSON can handle it correctly. All right, the JSON encoder that's built into Go. You can also set up something called JSONiter, I think it's called. Oh wait, we're saying suckas. With a Z, very important. So we're just going to return when anyone does a GET request to API/account. Hello, suckas. All right. So next thing we want to do is create this server, or the definition of the server. We're not going to listen yet, but we're going to create the server struct, which is a reference to an HTTP server. And this is the standard HTTP Golang server. So this router actually meets whatever interface or expectation the standard Golang library has for an HTTP router. So if that doesn't make any sense, no, I'm sorry, I'll try to talk slower. All right, so we add the address there and the handler, which is the router. Bada boom, done. All right, so, and in Golang in your structs, you always need the trailing comma. That'll get you a lot. All right, so now we have the server set up, and we need to do something called graceful shutdown of the server. And I'm just going to copy this code and then try to explain it as best I can. Starting here. So I have a reference link here. You can find it in the Gin documentation, and really graceful shutdown of servers is something you can find in lots of articles on dev.to and Medium and in GitHub repositories. But what we're doing is we're creating the server, or we're listening on the server inside of a Go routine. So this Go routine is just running separate from the rest of the application. And then I'm just going to log that it's running. And then I'm going to create a channel that accepts operating system signals. And then I'm going to notify this channel whenever someone does a SIGINT or a SIGTERM. So basically, if someone is running this application, it's going to block until someone hits Control-C. Or exits the application by another means. So this is what this line here is basically we're waiting for this quit channel to receive something. So this quit on the right of the arrow pointing to the left means basically we're blocking until something comes into this channel, and often you would assign what's coming out of the channel on the left side of the arrow, but really we're just doing this to block the subsequent code, i.e. the code down here, until the quit signal comes. All right, so in here we basically just have a timeout that basically is just going to cancel everything and shut it down miserably and horribly if something goes wrong. And then we're going to shut down the server here in this line and print out that the server shut down. So basically this all waits until someone hits Control-C. So let's give this a go. So now you actually see that we have a listener inside of Gin. It was kind of nice at this endpoint, and we can see that we're listening on port 8080, and let's hit Control-C to terminate this process. And you see the shutting down server with suspensive marks. All right, so I hope for those of you that program in Go, this is obvious, and those of you that don't, maybe you're coming from another language, hopefully this is reasonable. Okay, the next thing that we want to do is set up this Go file to run inside of a Docker container. So to do that, we're going to create a Docker file. And the standard way to do that is just to call it Docker file with no extension. I don't know if the capital makes sense. Maybe we'll see if it seems to know it's a Docker file in VS Code. But let's just create this Docker file. And this is basically going to tell us how to build a container that can run Golang. So I can't go over Docker too much, but usually you start from a base image that people that are a lot smarter than you created. I'm not saying you shouldn't understand what you're using, but at some point you have to get started. So let's start this from a base image, and we use the from keyword in Docker, and we're going to use the Golang Alpine image. Next, we're going to say as builder. This is something called, when we label from with as, it means we're using something called a multi-stage build. And that means that we can build one container. In this case, we're going to build a container that builds the Go application. And then we can use that container to create a leaner container that only contains the binary for the Go code. So when you run Go, it creates a binary. You can create these binaries for all sorts of operating systems, and then we'll deploy that in a separate container. For development, we only need this builder container. We're actually not going to use the lean container here, but I think it's useful for educational purposes. All right. Whoa, I just had some auto-completion there. All right, so next thing we're going to do is create a work directory. And this is basically defining the base directory in the container. So anything we do in this Docker file will now be related to this directory. Or I should say anything inside of the Docker container will be related to this directory. So we're just going to create one called Go source app. All right. And then the next thing we're going to do is set an environment variable so that Go knows that it's using modules. When we did that Go mod init, I think that's actually the default now, so I probably don't need to set this. I just copied that from someone else probably. All right. The next thing we're going to do is run. This allows us to run like a standard bash command or shell, probably not bash, just standard shell command inside of the Docker container. So we're going to go and get a repository that I'm going to copy and paste here. And this repository is called Reflex. Reflex will be used for live reloading this application in Go. So it's basically just a file where program where you can set up a regular expression to watch Go files, and then it will rerun the server whenever one of those file changes. So if you're coming from Node, I know I'm using this a lot, but most of the web tutorials are Node and React and MongoDB. If only we could have another MERN course out there, that would be fantastic. Yes, I said that somewhat mockingly, even though I also like working with React and Node, so I'm a hypocrite. All right, so the next thing we're going to do is copy the go.mod file into, remember I said the work dir, we're going to copy it into Go source app. So basically the first thing we're copying is from the host machine, my computer, into the Docker container. You could also use like a star here, but to say all Go files, but I'm just going to separately copy the go.mod and the go.sum. All right. The next thing we're going to do is download all of these packages. So I'm going to run another shell script. And I'm definitely going to have a typo here. I should have just copied and pasted, but you know, learning experience. So then we're going to do something. We're going to copy all the rest of the files with dot into Go source app. So that's what we're doing here. After we've downloaded the modules, then we bring in the source files is basically what that's saying. And then we're going to build the Go executable into the output file called run at the root directory. So basically we're going to create a run file, and then we're going to put that in the app folder of the container. All right, so that is the builder stage. This is how we create the binary. And now I'm going to do the next stage, which is what you would use for your production container. So let's again create an Alpine. So this is just a very lean version of Linux. And this time you can see we're not using Golang Alpine. And the next thing we're going to do is some setup for certificates and the directory in this production build, which is a little different than before. And finally, I'm just going to copy and paste these lines. We're going to copy, this is actually an interesting line. We're going to copy from builder the file run. Remember, we created that here, and I don't know why everything's highlighted with this extension, but okay. And then we're going to copy that into this root folder. We're going to expose 8080, and then this command is just going to run that executable. That's all it is. So if you had multiple lines here, you could, multiple commands or arguments, you could add them in this array. So that is going to create our Docker container. So that's basically it for this step. All right. So what do we need to do now? We're going to, in the root level of the application now, see that I'm going over to the memrizer. We need to create a Docker compose file. And this is usually .yaml like this or .yaml. So you know it's a YAML config file. Those of you who do any DevOps, I don't do much, but I do a little. You gotta fall in love with YAML. You gotta dig it. It's basically your life, I think. Anyway, what Docker Compose Up is, it's a file that lets us set up various containers to automatically run with a single command, Docker Compose Up. So in this application, we're going to be running containers with Postgres, with Redis. Our 4 different applications, we're going to have an account client, an account server, a memorization client, a memorization server, and we're going to have Traefik, which routes the URLs to the various applications, the URL traffic. So able to get this to run easily, we're just going to use this Docker Compose Up, and it will run all the containers for us. We can even do things like say that this account container depends on Postgres and Redis to work. And so it will make sure Postgres and Redis run first. I think I have that right, before account runs. All right, I'm just rolling with this. First tutorial video ever, so probably lots of uhs and lots of errors, but I hope you're enjoying it. As you can tell, I'm trying too hard to be self-aware, and I said again. So let's copy and paste the YAML file for this Docker Compose, and you can type along. I'll try to go through slowly enough so that you can copy. So version basically just defines what some of these keywords are supported. In this case, we're not using anything that's cutting edge. These are basic things that should work with any Docker version 3, maybe even 2 point something, but at least version 3 point star. The next thing we're going to create is services. These services define the various containers that we'll be using in development. So in YAML, everything is organized by 2 spaces or tabs. I forget which it is technically. My environment is set up for that long ago. But you can see we're going to set up 2 called account down there, and up here, reverse proxy. So the reverse proxy is this Traefik tool that's going to handle the routing of URLs. So let's see what we have here. So we're using a base image of Traefik version 2.2. Then we have a command key. And so this is basically going to run Traefik, and then it's going to take some command line arguments. And this is the most normal way I see in tutorials of running Traefik inside of Docker. First of all, we're going to use api.insecureTrue. which allows us for development to just use HTTP without TLS. A lot of people like Traefik because it's easy to set up certificates and TLS, but we're not doing that now, or at least not yet. I haven't done it in my own application yet. Maybe I will at the end if you guys really want it. And if any of you guys actually exist. All right, so next we're going to say we're using a Docker provider. This basically means that this reverse proxy needs to look for other Docker containers to be able to route traffic to. And then this next one adds on that. It's saying that don't expose every Docker container by default. I have all kinds of containers from previous Kubernetes setups. Because I'm using Windows subsystem for Linux, it spawns some containers. I do not want to worry about routing to all those. I don't want to see them in my dashboard. Wow, I sound kind of whiny. Okay, next, we set up ports that we want to expose. For those of you that aren't familiar with Docker, we basically list two ports. The one on the left is a port on our host machine, and the one on the right is the port on inside of the container. So we want to make sure that port 80, which is the standard HTTP port inside this Docker container, is mapped to 80 on my computer. So if I type in a standard URL in the browser, it routes correctly to that Docker container. 8080 is just used for a web UI that displays all of the different containers that are running. Or in other words, all of the ones that have a configuration for Traefik. And this volumes is actually kind of beyond me. It takes a lot of understanding of Docker and Linux, but supposedly it's so that this tool Traefik can listen to events in Docker. So if you create a new Docker container or some network is spawned in Docker, I won't go into details, Traefik knows to automatically add that container. It can see those changes. All right, hopefully that's reasonably clear. Next, we're going to create an account. And this is basically going to host the Docker container we just showed, or we just made in the account. This one here. So that's why when we use this build key or argument, we give it a context, meaning look in the account folder. We don't list Dockerfile because by default, the Dockerfile is going to, the file called Dockerfile will be found. So we just have to say look in the account folder, and we can use a relative path. Then we say target. Now remember in this Dockerfile, I said we had this builder stage up to this point. We don't care about this lean build. We just want to rerun the Go build and run the program in development with this stage. And I didn't need to do this for this application or for this tutorial, but it was something I learned. And so it's nice to know you can specify a target of a multi-stage build. We give the image a name. We expose port 8080. So if you remember, that's related to this account. We start it on address 8080. Sorry, this account server is on port 8080. I'm very apologetic today. I don't know why I feel so much remorse. All right. So I'm not 100% sure that you need to expose because Traefik can find this, but I think I had some problems earlier. So play around with that. See if it works for you without exposing that port. Because all of the routing from the reverse proxy to the account should be done internally. All right. So next we add labels. These labels are what tell this provider to look, it's what tells Traefik to look for this container. So first thing we do is we set a label saying to enable Traefik. And that corresponds to this setting saying I'm not exposing all containers. So for Traefik to be able to see that container, we have to set enable to true. And probably the bread and butter, the most important step is to create this rule. So this rule is basically saying create a router called account with the rule that if we have a host, we're going to call our company Malcorp We're not trying to hide that we're evil. We're not trying to say, I better not say that because I'm putting this on YouTube. All right. With that saying, we're going to use a base URL for all these applications of malcorp.test. And then if we have a path of API account, that's when Traefik should route things to the account application. So this is how we configure what URL goes to what service. It's actually defined at the container level. You do have the ability, as you would see like in Nginx, to define a config file for the reverse proxy, and maybe that fits your workflow better. This here environment for now, we'll come to this later, but it's just basically a way to say that this is a development environment and it sets an environment variable inside of the container. And actually, I may change how we do this time. This volumes basically says that we're mapping folders inside account into that folder inside the container with our application. And that's the folder, again, we defined here. And lastly, we're going to run a Reflex command. This is that live reload tool. Remember, we downloaded it inside this Docker container. So we can run commands inside that container, basic shell scripts, and we're going to say reflex-r, which means use a regular expression to look for any Go file. And this is a regular expression. You can see I have to use $2 because normally that would be getting an environment variable inside of a shell script. And then we're going to run the shell command, go run, and // I could use main.go right now, but we'll actually put some other main package files in this account folder. So I need to be able to see all of those, I need to use the // Maybe this isn't the best way to do it, but that's how we're going to. All right, so that looks pretty good. The next thing that we need to look at is creating a host file. So I've created this malcorp.test file, and in order to be able to go to my browser and type malcorp.test and then it navigates to this, our system, our actual local machine, needs to know that this is kind of, alias isn't the proper term, but this should be routed to actually localhost or 127.0.0.1, the IP address. So to do this, usually you would run something like, I'm in Windows subsystem for Linux here, so you would do sudo, it's in the .etc.hosts file, and I'll run nano just to open up a simple text editor and enter my password. I just entered my password wrong. I keep forgetting it's different than Windows. And you can see here, I've basically mapped malcorp.test to localhost. So you'll just need to add a line like this. If you're on Mac or Linux, it should be at this path, .etc-hosts. Again, this is in the written tutorial if you need to look that up. And if you're in Windows, the path should be, well, you can see here some of my recordings that I'm working on. So you're seeing the behind the scenes action here. So the path in Windows, I'm just going to copy this over here, waiting, is here. So it's, I guess I have to open it first. Let's open it in code. Why am I not in code? All right, I'm just going to open it in Notepad. Bring Notepad into my visible area, and you can see that I've added malcorp.test here. And in my case, since I'm on Windows subsystem for Linux, I think I need to add this in both places, so my browser and the Docker handles this. So you may need to do the same, or one or the other. All right, so we have this set up, and now it's time, the moment of truth, to cross our fingers and see if this works. So actually, I'm going to make another terminal window here, and cd up one directory into the root memrizer folder. And then I'm going to try running docker compose up. Oh boy. And you can see it's downloading all of the dependencies inside of the account container. It gives it a default one. And it's listening on port 8080. I'm trying to see if reverse proxy has any errors. It looks pretty good. All right, boys, girls, whatever you are. I'm going to get in trouble for saying stuff like that. Let's go to malcorp.test. And, of course, we have to go to API/account. And clearly I tried this before. Oh, it says, hello, suckers. That's great. It's working. It's the Christmas miracle, or whatever holiday you celebrate. So let's now go back to VS Code. I went to terminal. Sorry there. And you can see this nice colored logging I briefly mentioned earlier that we have a GET request. Let's make this bigger. And it returned a status of 200, the time for the request to API account. So that's great. Now let's see if that live reload works. So what I want to do here is change the response that we're going to return to, so I've suddenly become friendly and found civility in my life. So I'm going to say kindly folks. I'm really in a wacky mood saying this kind of stuff. All right, so hello, kindly folks. So I'm going to hit Control Save. Watch in here to see if it reloads. You see, it said it got that SIG signal. It restarted the app. Let's go back to the browser, cross our fingers, and it's working. All right, so I hope you've learned something from this long tutorial. I found this project very useful, learning to set up Traefik. It doesn't have the best error reporting when you mess up, but I hope that this could be useful to you in scaffolding out your own projects. Next time, we'll add routes to our GIN router and also cover some of the application architecture. So, hasta el próximo video. Nos vemos. See you next time. Ciao.